Hello friends, welcome to the second video on the Laurent series. First we will make an introduction to the Laurent series, a series of f of z which is expressed as positive and negative powers of z, like summation n varying from 0 to infinity a n z minus a power n plus summation n varying from 1 to infinity b n divided by z minus a the whole power n is called as the Laurent series. Terms that contain the positive powers of the function f of z is called as the regular part, and terms that contain the negative powers of your f of z is called as the principal part. We have elaborately seen expressing a function f of z as Laurent series in three different regions or zones in our first video. This will make us comfortable with one more problem in the Laurent series expansion. So the problem is like find Laurent series expansion of the function 1 by z plus 1 into z plus 3 in powers of z plus 1 for the range 0 less than z plus 1 modulus less than 2. The primary thing to notice over here was normally we express the Laurent series as powers of just z because we will be expressing it as a function of z, and our range also will be as 0 less than z modulus less than 2 and so on. But what's different over here is they are not asking us as powers of z, but they want us to express as powers of z plus 1. So that makes the problem a little different from the one which we saw in our video number 1. So how to handle this situation? We are going to handle this by the substitution method. So what we are going to do over here is we are going to substitute z plus 1 to be a secondary variable called as u. Therefore the function which was f of z 1 divided by z plus 1 into z plus 3 will now become a function of u, where I have this z plus 1 to be replaced as u, and what about z plus 3? Z will be equal to your u minus 1, so z plus 3 will be u minus 1 plus 3, which makes it as u plus 2. So the function of u will be 1 divided by u into u plus 2, which has to be expanded as a Laurent series in powers of u in the zone or in the region. So the region also will get changed according to the substitution. So this becomes 0 less than modulus of z plus 1 is replaced with u less than 2. So the problem now becomes expression of f of u, which is 1 divided by u into u plus 2 as an Laurent series expansion valid for the region 0 less than mod u less than u. Now I have modulus of u to be less than 2. We know that the series is valid only for modulus less than 1. So divide by 2 to make it less than 1 so that the series converges. Hence you have to pull out your 2 outside so that the second factor gets replaced as 2 when it comes outside, makes it as 1 plus this u will be divided by your 2. Hence I have this as 1 divided by 2u into 1 plus u divided by 2. Now I have the format of the requirement. Take it to the numerator, rewrite it as 1 plus u divided by 2 power minus 1. Now we can have the series expression as one positive and the other negative term, which means we need to have alternatively positive and negative series to be generated when the signs are alternatively positive and negative. So it is 1 minus u divided by 2 power 1 plus u divided by 2 to the power of 2 minus u divided by 2 to the power of 3, and so on the series moves. Hence I can rewrite this to be 1 divided by 2u The entire of this expression can be rewritten as summation n varying from 0 to infinity. The term is u by 2 power 1, 2, 3 and so on, starting with 1. So you can replace it as u by 2 the whole to the power of n. This generates these terms. But how to generate an alternative positive and negative sign? This can be taken care of with a minus 1 the whole to the power of n. So I have my function f of u to be evaluated as a Laurent series expression or a series of the format 1 by 2u summation n varying from 0 to infinity u by 2 power n into minus 1 power n. But we need to keep in mind u was the substituted variable which we introduced for z plus 1. My original series is in terms of my z. So how to handle it or get it back to? So wherever you have u, retrace your u back to your z plus 1. So resubstituting, your f of u will now turn out to be a function of z by replacing your u with z plus 1. So the function will now be z plus 1 summation n varying from 0 to infinity z plus 1 divided by 2 whole to the power of n and minus 1 power n. So this is going to be my series expression or Laurent series expression of the given function in powers of z plus 1. So keep in mind, whenever you have an not an independent variable, try to substitute it for some other independent variable and then give the expression as in the worked in the same way. Final substitution has to be resubstituted back to your original variable. This completes the problem in Laurent series. Thank you.